For our last couple classes, we're going to talk about functions and then also cardinality, which is a way of describing the size of a set. And in order to describe the size of sets, we're actually going to need to refer back to functions. And so to begin with, we're going to need a more formal definition of functions. And so of course you've seen functions before, but we want to write something down that we could use in proofs. And so we're going to define any function f, which maps a to b, to be any assignment where for every a and a, there is exactly one assigned f of a in b. And so exactly one really has two different components then. We could break this down into saying it has at least one f of a in b and at most one f of a in b. And in your textbook, that is the way that they define a function. But for here, we're just going to combine that into that exactly one terminology. It's also the case if we want to connect things to what we've seen before, we could view f as a relation from a to b. And that's just because relations, by definition, are ordered pairs. And so we could let a comma b in f just be shorthand for f of a equals b. And so sometimes when people are being particularly formal, they refer to functions in this way as ordered pairs. We'll need a couple more words to talk about the functions. And so whenever f maps a to b, a is called the domain and b is called the codomain of the function. So let's look at a couple examples just to make sure that this terminology is making sense. And so if we have f of x equals x squared on the set 1, 2, 3, then first of all, we know that f of 1 is equal to 1, f of 2 is equal to 4, and f of 3 is equal to 9, just by squaring them. And so now if I want to know the domain of this, then I know that the domain is the set that has all the inputs to f. And so in this case, that would just be 1, 2, 3. Then if I want to talk about the codomain, it's actually not clear from what's written what the codomain is because the problem didn't specify. And so it's really valid to have anything as the codomain as long as it includes all of the outputs. And so in this case, that would be anything that includes 1, 4, and 9. And so it could be, for example, all of the reals. That would be a valid codomain for this function. But it couldn't be the set that just contains 1, because then 2 wouldn't have an assignment in this set. If we did want to talk about the exact set of outputs, this 1, 4, 9, then this we could refer to either as the range or as the image of the function. And we'll talk about that more in a minute. Your textbook uses the term range, but other sources often use the term image. Okay, so the last thing I want to make sure is clear is how we could connect it back to this ordered pair notation up here, so this a comma b and f. And so what we could say is that this function f is equal to a relation where it maps 1 to 1, it maps 2 to 4, and it maps 3 to 9. And so that is the list of ordered pairs which define this function f. Okay, let's look at another example here. Often we'll want to check whether or not a function is well defined. And so a function being well defined, that's just terminology for saying that there's exactly one assignment for every input. And so, for example, we could look at this function f, which maps r to r, according to the relation that f is all of the ordered pairs where x squared plus y squared is equal to 4. And so we could then graph what this set is here that I underlined in blue. And we could see that, of course, this corresponds to that circle with radius 2. And so this looks awfully similar to some of the questions that we've had on the last couple exams. And so if I wanted to, then I could see that the ordered pair 0, 2 is going to be in f. And also the ordered pair 0, minus 2 is going to be in f. And that's because in both cases, 0 squared plus 2 squared is 4, and 0 squared plus minus 2 squared is 4. And so they're both in f. But that's a problem. And that's because these inputs right here, the 0 input, has 2 outputs. Or in other words, it just has 2 possibilities that could go in the second part of the ordered pair. And so it's not a function. If we want to relate this back to pre-calculus, then really what we're testing right here is the vertical line test. And this function does not pass the vertical line test because there are vertical lines where there's more than one assignment on that line. Or in other words, more than one spot where the function intersects that line.